Okay, for today, this is a review for the Chapter 15 test, which is on inverse trig and solving trig equations. Here's an example of an inverse trig question where you're given cosine with a little -1. What does that mean again? Inverse cosine. And do you remember that cosine like that has special restrictions? Would you please make one of these little charts of where you can do what function? There's like, maybe there's a little thing over here too that's important. Something special about there. Fill out the restrictions. Where are certain things allowed? Okay, that one on the top. What is that one on the top, sir? Oops, sorry.
That's the cosine.
That is the cosine. Is it actually cosine? Inverse cosine.
Does it not touch?
Good question. I'm being a little sloppy here, but you tell me. Does cosine have asymptotes? No. So cosine touches. Which one does have asymptotes? Tangent. So tangent is the one that doesn't touch. And that's this one over here. That one's tangent. Or I could have said that one's the other one that's over there, which is what? Inverse sine.
Yeah, and sine are the same, right?
They are the same, except the tangent can't touch the edges because it's got asymptotes there. So can you do tangent of pi over 2? It's a good question. Regular tangent or inverse tangent? The answer is going to be the same. Tangent of pi over 2. Here's pi over 2. Can I do tangent of that? No. The way I would think of it is this. Inverse tangent isn't allowed here, it isn't allowed here, and it isn't allowed right on that line, and it's not allowed on that line. See what I'm saying? Because inverse tangent can't touch the edges. Here's another way you could think of that. Here's a graph of tangent. Everybody please make a quick graph of tangent and label where those asymptotes are. I'm glad you're putting those away. Is your iPad awake yet or not? It is, excellent. Would you please graph tangent for me? So Mr. L, you were labeling him like a boss, and?
The one on the right, pi over 2.
And the other one?
Negative pi over 2.
You are correct, sir. All right. And does this follow that adage that the asymptotes are pi apart?
Yes.
Yes, it does. Which says that the period of tangent is what? It's pi. Because this whole distance from here to here is a half pi plus a half pi makes pi. So tangent, the period of tangent is pi. And that's what tangent looks like. Do you see now why you can't do tangent of pi over 2? There's nothing there. It's an asymptote there. All right. Next, about this picture. What's the little green zone? I call it the dead zone. Nothing could go there. Can't do any inverse trig there. How about the yellow circled area?
That's the negative zone.
That's the negative zone. You are right, sir. So a lot of times people get an answer there, and they go like this. They're like, ooh, I've got it figured out. I know this is a 30. And then they'll say, so the answer isn't 30. They're smart enough to know that. But they think, oh, so I'll say it's 330. Not if you're doing an inverse trig question. Doing an inverse trig question, it would be what? Negative 30. And that's why, next review topic, for inverse trig, what's the biggest answer you can have?
2 pi.
0 is not very big. Can you be at pi over 2? Is that a possible answer for an inverse trig question?
Yeah.
Can pi be a possible answer?
Yeah.
Can you go past pi? No.
No, 'cause then
As
it
soon as
goes
you
back.
do, you'd be in the dead zone. It wouldn't work.
Oh,
Nothing works down there.
I thought we had to use radians. I don't think degrees for radians. Or is that not always?
Pi is radians, and I was using radians, and I said you can't go past pi.
The last one we did.
Okay, so just to clarify, are degrees illegal now?
No.
They're not illegal, but your answer is usually supposed to be in radians. But that still means, what's the biggest? I asked this question. what's the biggest answer you can get? And it is pi, also known as 90 degrees. It's the biggest answer you can have. And that doesn't even work for most functions. If you're getting an answer of 90, it better be for, no, not 90, sorry, this is 180. I think I was saying 90 there. Anyway, 180, if you get an answer of 180, do you get it better be for a inverse what? Nope, inverse tangent's over here. Inverse cosine. It better be an inverse cosine question because that's the only one that goes over there. All right, now let's actually do some inverse trig. You ready? Inverse sine of 1. What? How do you draw a triangle for that? You can't. So don't draw a triangle. Figure out what zones are allowed. Don't draw a triangle, and therefore you must be on a quadrantal. Pause for a second while you figure this one out. Okay. Would you agree that only a couple of quadrants are options? KL, can you tell me which quadrants are thrown out because I'm doing inverse sine? Good. 2 and 3 are out. And can it be there? Can it be here? Can it be here? Yes, it can be any of those 3 places. Because this is 1 over 1, you should know that sine can't have a hypotenuse that's the same size as another leg of a triangle, so there's going to be no triangles involved. No triangles were harmed in the filming of this movie. That spot, is that it? Are you sure? How about what spot is that? What comma what? 0 comma 1. What's sine? Y. Isn't y 1 right there? So isn't that the right spot? I think it is. Final answer, pi over 2. Raise your hand if you would agree that it's pi over 2, because you are right. Good job. Okay. Let's do something very similar to that. Let's do inverse cosine of 0. Excuse me. Inverse cosine of 0. Pause for a second and try that one. Okay, inverse cosine. It's allowed from here to here. So I'm going to do it the other way. Can't be here, can't be here. Then, is this a normal place? Are triangles normally running around with sides of 0? No. So this isn't a normal place. It's either here, here, or here. And then you got to ask yourself, cosine is about y, x, or y over x. Which one is cosine? Cosine is x. So x is 0. This is a place where y is 1. Could that be a spot where x is 0? Yes, it could. Is this a spot where x is 0?
Yes.
Over here? No. Is this a spot where x is 0? No, that's a spot where x is -1, so it can't be there. So we must be here, and what's the answer again?
Pi over 2.
Pi over 2. Raise your hand if you had pi over 2. Okay, awesome. Now, let's do a nested trig question. Tangent of inverse cosine of -1. I don't know. They're not supposed to be easier, but I never think they're that hard because, you know, at the end of the day, once you're done with that part, you're just doing tangent of a triangle. So you might be asking, is that like an R2 question? Actually, it could be if we make the numbers super easy, or if the numbers are more weird or difficult, it could be an R3. So it's either a hard R2 or it's an easy R3. KB, can you tell me what to start with? Like, let's say, act like you're explaining this to your younger and obviously much less intelligent brother.
Yeah, okay, where we say you're gonna wanna draw the graph first,
Bingo.
and then you know cosine has to be in 1 or 2.
Excellent.
And cosine is x, so when x is -1, y is 0.
Is that this spot?
Yeah.
It is. So that spot's what comma what? We better like finish this. What comma what is right there?
-1, 0.
Excellent. Is that the spot where cosine is -1? And what is that? Pi?
Yeah.
All right. Now, this is going to bring up an interesting point. Question is, what's the tangent of pi? Now, use your big brain. Try to figure out what to do. I know some of you are thinking, it's 0. Some of you are thinking, there is no answer. Some of you are thinking, no, it's like pi over 2. Some of you are going to give an actual right answer. So at this point, what is the question? Tangent of pi. That's it. You don't have to carry around any of the old baggage of I was doing it in this quadrant or that quadrant, or just restart the question. Don't think about, do you see any inverse on this? No, we're done with all that. Now it's just tangent of pi. Where is pi? I hope you remember it's over there. And some of you are like, oh, you can't do that. No, that's if it was inverse trig. There's no inverse on this problem. It's just tangent of pi. There was inverse on the one on the inside, but we're done with that already. So what do you think the final answer is, sir? Yes. That spot is something comma something.
-pi.
Hold on.
Oh, no.
That spot is called -1 comma 0.
Oh, yeah.
And you want an answer. I know what you're thinking. You're thinking I could get there with -pi, but that's not the question. The question isn't an angle. The question is a side ratios. So now, what do you think the final answer is? I'm going to give you a hint. If this was sine, I'd say grab the y. If it was cosine, I'd say grab the x.
0.
It is 0 because it's 0 divided by -1, so the answer is 0. Raise your hand if you had a 0. Okay, awesome. Any questions on that one? Why aren't we drawing a triangle is a good question. Because if you're at one of these spots, how are you supposed to draw a triangle for that? It's a flat line that goes out. If we were here, we could draw a triangle. But when they're on the quadrantals, you can't draw triangles. You have to use the points. Okay, yes.
What'd you get? 5 for inverse cosine and
Okay, backing up a notch. Inverse cosine and -1. So cosine of, if we rewrite this, do you get it's kind of like this. Cosine of some angle equals -1. That's kind of what we're trying to figure out. Except it's got restrictions. And cosine, inverse cosine, can only be up here. So we were in the right zone.
Oh, I see. Okay. Fascinating.
And then since cosine is the x, I wanted a place where x was -1. So that's a spot where x is -1. And therefore the answer is pi.
I see.
All right. Okay. Good enough. That's a whole bunch of inverse trig. Now, what else is on this test? Solving trig equations. And there's two kinds you have encountered. One is where you have a problem like this. Actually, let's make it 3 theta. The reason is if it says 2 theta, you could actually grab something off the sheet and put it in. But you won't always be able to do that, because if it's like cosine of 3 theta, you won't be able to pull anything off the sheet. There's nothing on the sheet that's equal to cosine of 3 theta. All right, equals 1.
I can't even see.
All right, I am in your way. It is interesting how I actually, in a way, I block more people when I'm using the iPad, because Then if I happen to be sitting like in the front row somewhere, anyway. Okay, so now, who remembered that we replaced this with a u? Remember? Okay, good. Then this is cosine of u equals 1. And then you do the whole thing where you go like, oh, cosine's the x. And where is x equal to 1? And did you realize it was that spot? And therefore it's 0? I know that's weird, but then u must equal 0. But if you ever have a u in your answer,
You're an idiot.
you are wrong. You can't leave it with a u because that was a substitution. U gets replaced now with 3 theta. And then it's very tempting right here to just go, well, when I divide by 3, 0 divided by 3 is 0, and the answer is 0. No. Why can't the answer be 0? Who remembers what we're supposed to put right here? 2 pi k, very good. Liv? Now that we say plus 2 pi k, now we can divide everything by 3, or I like actually to multiply by 1/3. In all 3 spots, it is kind of wasted time there on the 0 because it's just going to be 0. But theta equals 0 plus, which means I don't even have to write it. Well, I'll write it. It won't hurt anything. 0 plus 2 pi over 3 times k. That means the period of this thing is 2 pi over 3. And each time we move over 2 pi over 3, we get another answer. All right, so then, at least there was only one answer. A lot of these have 2 answers, so you got to do this twice, but this one only had 1 answer. Because there's only one place where x equaled 1. Right, cosine's x, right? So there's only one place where x equaled 1. Yes, sir?
Wait, so why is it 0 there?
Why is it a 0 there? Because 0 was the angle that we found right here. Cosine of 0 was equal to 1. I know that's a strange place, but it's this quadrantal right there. That's why it's 0. And now 0 times 1/3 is still 0, so yeah, there's still a 0 there. And then I'm going to put in k equals, what do you say, sir?
2 by k.
Just k. K is my counter. I should start with k equals, I'll help. K equals 0, and then I'm going to do k equals 1, and then I'm going to do, what do you think? K equals 2, and then I'm going to keep going until I get an answer that is bigger than what? Bigger than 2 pi. If this had been tangent, tangent might have a different, well, it does have a different period, so then that could be different. But anyway, this is all about answers between 0 and 2 pi. So when I put in 0, I get 0. When I put in a 1, I get 2 pi over 3. When I put in a 2, I get 2 times 2 pi over 3, which is 4 pi over 3. Is that bigger than 2 pi?
No.
No, it's not. So we need to keep on going. K equals 3. So that's
That's just 2 pi.
I'm putting these numbers into k.
Oh.
And so now I got k equals 3, so I'm going to go 3 times 2 pi is 6 pi over 3. Uh-oh. That is 2 pi.
So you don't get it.
But do I include it or do I not include it? Here's the exact directions. 0 is less than or equal to theta, which is less than 2 pi. Don't include it. It's 2 pi. You can't include it. It's a big deal. Here's another way they write it sometimes. 0 to 2 pi, whereas a parentheses on the 2 pi and a bracket on the 0. That's saying 0 is fine, 2 pi is not fine. All right. There's an example of one of those from beginning to end. You'll get a chance to practice it tonight on your homework. Yes?
You know how you said if it's like 3 theta, you'll have 6 answers?
Yup, because we only had one answer in the first place. Do you get usually problems like this? There's 2 answers.
Yeah.
If there'd be 2 answers, you times it by 3 and you get 6, but there was only one answer. to times by 3, and so we got 3 answers. So the safest way to say it to you, and I have always said this, is keep going until you get to a number that's too big. That's the safest way. Just keep on adding the same amount every time until you break the limit. Okay. So the last kind, the last melon. It's kind of like this. That's a quadratic. How do you solve quadratics? You factor them. I can't factor it the way it is right now. I can't work under these conditions. Excellent. I'm adding x squared to both sides as we speak. And I get x squared plus 3x plus 2 equals 0. Now can I factor it? Sure you can. All right, except it isn't x squared. It's sine squared x plus 3 sine x plus 2 equals 0. Do you get what I just did there? I changed it into a trig problem because that's more likely what you'd have on the test. So imagine it looked like that. Can you still factor it? I hope so. Try it. ZL, what do you think?
I haven't done it yet.
Why?
Help me start at least.
You have sine on both.
Excellent. You aren't going to have too many choices on this next thing. What times what makes 2?
1 and 2.
Aha. And since they're all pluses, plus and plus. Now, this one's going to work out kind of strange. One of these works nicely, the other one gets weird. Let's see if you can handle it. What do you mean? Aren't we done? I got it factored, and it equals 0. No, you can't be done. You have to now write sine x plus 1 equals 0 and solve that. The other one gets weird. How in the world can sine of x equal negative 2? Can it? I encourage you every now and then, if you get stuck, to think about the graph. Just for a second, would you agree this is the sine graph? How high does it go? How low does it go? So when it wants you to go to negative 2, you can't. You can't. There's no answer. It's like y equals sine of x is the graph. Y equals negative 2 would be a line that was running down here. And it's like, where do they intersect? They don't, ever. This one, no solution. This one, definitely a solution. Solve that one. IE, Internet Explorer. Can you tell me what quadrant I should be in? All right. And am I like restricted by some inverse sine rules or something? Why do you know what quadrant I should be in? How are you doing that? Were you told by a gremlin, or how did you find out that it was those quadrants?
Can I pass for a second?
Yes, I'll come back to you. Hot seat is a little too hot for that moment. Okay, RW. Tell me what quadrant we should be in. Oh, there's 2 RWs. Dang it. Okay. Okay, there's an RW up here. Go ahead, sir. You're saying 3rd and 4th quadrant. You're saying I should throw these out. Can you tell me why?
Because sine is negative.
The sine is coming out negative, and that's only happens in those 2 quadrants. All right, good. So now I'm going to make this one, and I'll make this one. And there are some of you getting like the heebie-jeebies, like, wait a minute, you can't be here. That's the dead zone. You should be, but it's a smart person trap. since it's not an inverse, we can be there. But a smart kid would at least know that that's the dead zone and I should be careful there in this unit. But since this was not an inverse trig question, we can be there. All right, so now sine is opposite over hypotenuse. Wait a minute. How am I going to have a hypotenuse and opposite be the same size? I can't. So one of the things we don't talk about too much is sine can be negative, sine can be negative in those two spots where the green triangles are, but it can also be negative here or here or here. So which spot is it? 0, pi, or 3 pi over 2? Can you explain why you think the answer is this one, 3 pi over 2? Dice of Destiny. You, sir, give me a number from 1 to 6. Number from 1 to 6.
5.
Row 6. Or sorry, row 4, person 5. 1, 2, 3, 4. Person 1, 2, 3, 4, 5. It's you, Internet Explorer again. Back on a hot seat. Is he not the 5th kid? Oh, my bad. I counted wrong. Okay. Sorry. So 5th kid, and are you ready? Can you do it? What I'm asking is, how am I going to figure out where sine is -1?
It's 3 pi over 2.
And why? Prove it to me.
Uh,
You think it's here.
Sine is -1.
So what is that point? What comma what?
0 is negative.
And the sine, which is also which letter?
Y.
The sine is the y, and y is -1 there. You are correct. It is 3 pi over 2. Raise your hand if you had that in the first place. Okay, good. Okay. Yay. How did we do that one again? That we were in the middle of factoring, and then I switched it up on you. Here's a more likely scenario. Sine of 2 theta equals sine of theta. Whoa.
Oh.
All right, first thought. You could think about doing a u substitution, but don't do it. That's not it. Who's got other ideas? Substitution. You're going to pull out what? Put in what?
Pull up my sheet.
Okay. What if you're scared sheetless? Does anybody know sine of 2 theta?
Yeah.
What is it?
30.
It's not 30.
Pi over 6?
I have asked that question so many times. Sine of 30 is 1/2. That's something completely different. What is sine of 2 theta? 2 sine. Correct.
Looking at the sheet.
That's his brother texted him.
Yeah, nice. Brought it back to that. I appreciate that. All right. So now, hey, you got the text your brother. Be happy. So now I'm going to subtract what from both sides?
You can subtract sine of theta from both sides.
You are correct, RH. So tell me, after I've subtracted sine of theta from both sides, you have it equal to what?
0.
And then why did we even do that in the first place?
To get it into a quadratic.
Kind of.
Sort of.
Instead, to get it so that you can factor. And yes, oftentimes that is a quadratic, but this one isn't because there's no squared. It's okay. So next, call on anybody you want to factor it.
Charles.
Okay?
So what you should do is put some parentheses.
Actually, no, I don't want to call
He's just buying time.
Can I call someone else?
No, it's too late. You've already called in him. Can't take it away now.
Push 2. Oh.
What goes on the outside? Hint, what is there in both of them? There is not a 2 in both of them.
This side.
There it is. Sine, sine, everywhere is sine. And then,
Cosine.
after I take this out, what's left?
Cosine.
All right. And then, is that it? Am I done? All right, he's struggling. He needs a lifeline. Help him out. -1, thank you. All right, easy. Now, that has to equal 0. Shh. And that has to equal 0. And this time you have 4 answers. Find all 4. I'm going to pause for a second. That has to equal 0. That has to equal 0. 4 answers. You should be good enough at this by now that this should fly. I'm going to pause while you give it a try. And this is pretty much the last thing we're doing. All right, so. Okay, here we go. We go sine theta equals 0, and then what? Well, there's 2 answers. Where is y equal to 0? Is there more than one answer? Well, is this a spot where y equals 0? Yeah. Is this a spot where y equals 0? 1 comma 0? Oh, yes, it is. So there's 2 answers. These are 2 spots where y is equal to 0. And some of you are still stuck in the, well, sine can only be over here. No, that's inverse sine. We're not doing inverse sine. Okay. So I got 2 answers, 0 and pi. On the other side, on the flip side, if you will, 2 cosine theta minus 1 equals 0. I'm going to skip a step. This always burns me, but I think I got this one. And then I'm going to make 2 spots where cosine is positive. How about this? Where cosine is negative, I better cross it off. Cancel, cancel. And that leaves me with an answer here. Cosine is adjacent over hypotenuse. And that's square root of 3. And I find that a lot of kids get this wrong because they know that the answers are 30 and 60, and then they just like quick guess one. What is it, 30 or 60? All right. At least we got 2 people giving answers there. Is it 60 or 30? 60. Shh, be quiet. Clearly isn't 70, though. All right. 60. But you can't really say 60. What is the final answer? Pi over 3. Is there only one answer? No. There's a whole bunch of pi over 3s. 3 pi over 3, 4 pi over 3, 5 pi over 3, 5 pi over 3. Pi over 3, 5 pi over 3, plus the other answers of pi and 0. Holy smokes, there is 1, 2, 3, 4 answers for this one. You are in heavy duty trig. Let's look back at this. All the things you had to know. You had to know that from an identities list. You had to know to rearrange the equation to equal 0. You had to know how to factor it. You had to know how to break it into this equation. Then you had to know which quadrant to be in. And oh, there isn't triangles. You have to know how to handle it when there's no triangles. There's so many things to know. That's why Precalc is hard. And people will ask me like, is Precalc like why is that so much harder? And it's because you have to know 12 things to answer one question. Remember back to higher algebra when the only question was x squared plus 9x plus 8? That was like a little tiny part of this question. In higher algebra, that would have been the whole question. You get what I'm saying? That's why Precalc's a step up. And that's why early in the year, I really try to get kids who don't have their basics down to really think, do you want to take honors Precalc for Pete's sakes? It's hard enough. And this moment, you are now caught up to the end of regular Precalc. If you were in regular Precalc, you'd be done right now. You'd be ready for the final. So what are we even doing between now and June?
Getting smarter than those counts.
Getting smarter. Yes, you are. You're going to be learning 4 units that are advanced stuff that is important, as evidence has been on in recent ACTs, like vectors. Yes, like Vector, the superhero. Yes. I commit crimes with magnitude and, no, what is it? With direction and magnitude. Anyway, so you'll be doing vectors. You'll be doing polar. Actually, polar's coming next. It's pretty cool. Anyway, my point, just reflecting on how much you've learned, you really have learned a lot. Okay, your homework for tonight is to do the odd problems on the worksheet that is there. But, and this is a big but, would you please go to Schoology and fill out a survey. I only want you to take about 6 minutes to finish this survey right now. please resist the urge to skip it. I really need your input. It's a survey about me. This is not a principal survey. I painstakingly took an hour and a half and made all these questions. And it's called Server's Survey. Would you please find it right now on Schoology?
Server's class.
Oh, fine.
Server's teaching survey.
Yeah, that. Server's Teaching Survey.
Snow day on Thursday, Mr. Server.
There is no way you're getting a snow day on Thursday. I'm going on record saying that.
It's gonna snow a foot though.
Not buying that you're going to get a snow day out of it because it'll be.
inches.
There's no way. What? I can tell you it's good to have a dream life, and I'm happy some of you have an active imagination. But there's no way you're getting a snow day.
It's less than 6. Yeah, I heard 16 even then. Yeah, they said 15 to 18.
All right, so for the end of the video here, I just want to remind you that you have a worksheet called Review Worksheet 1, and you're doing the odd problems. And if you're in my class, you should do the odd problems on that worksheet. The very first one's one of those substitute something and then factor it deals. All right, and that's all I have for you for today. If you're one of my students that's absent today, just please go fill out that survey. It'll just take a few minutes.